Assalamualaikum to Dr. Nazrin. For this lab, we use MATLAB commands for PID analysis, which is to analyze the effect of different value P, I, and D in a control system. Okay, so for the first task, which is 3.1.1, it's stated here in the questions. We need to generate a system graph without PID controller and determine rise time, overshoot, settling time, and steady state error. Okay. This is the coding. Okay. Then run. Okay, here is the graph. First, set the settling time, rise time, and steady state. Okay, it states here the rise time that I get from my results is 2.59 second, and then settling time 4.6 second, and the final value is 0.5. Okay. Next. For 3.1.2, with PID controller, first, when Kp is increased while Ki and Kd is constant. Okay. 3.1.2. Okay, this is my coding. Okay, from here we can see Kp value is increased, Ki and Kd is constant, which is same value, which is 1. Same here for Kp2, the value is 15. For the value of Ki2 and Kd2 is constant, which is also 1. Okay, and then run, and here's the results. So big this point and settling time. Okay, in here we can see system PID for PID2, the overshoot is 11.4, time 0.842 seconds. Okay, for settling time is 15.2 seconds, and for the red line, the settling time is 4.6. Okay, this is the result of when Kp increase while Ki and Kd is constant. When Ki is increased while Kp and Kd is constant. Ki is increased. Okay, this is as you can see, this is my coding. Okay, you can see here the Ki value is 3 in C1, and the value of Kp 15, Kd 5. And next we can see in C2 the value of Ki is 7, which is increased from C1 from here. Now from here we can see that Ki1 is 3 and Ki2 is 7, which is not constant, while Kp1 and Kd2 15 and 5 also have the same value in C2, which is 15 and 5 for Kp2 and Kd2. Okay, so we will run the circuit, and this is the results for my second task in 3.1.2. So pick rest point, setting time, and rest time. Okay, so as we can see here, for PID2, setting time is 0.678 second. Okay, and the rest time 2.59 second for the red one, and then for PID1, settling time is 2.3 second. Okay, this is the result of Ki increase while Kp and Kd is constant. Next is when Kd is increased while Kp and Ki is constant. Okay. So in here, okay, this is my coding. Same method as before. We can see that this time around, Kd is the value of Kd will change while the value of Kp and Ki is constant. Which you can see here, the value of Kp is 15 for C1 and C2, and the value of Ki is 7 for C1 and C2. And the value of Kd is changed from C1. For C1, the value of Kd is 3, and for C2, the value of Kd is 5. Okay, next we'll run the program, and we can see this is my result for when Kd is increased while Kp and Ki is constant. Okay, first respond, setting time, and rest time. Okay. Okay, for here you can see PID2, the overshoot is 1.9% at times 1.9% at 1.46 second. PID2. Okay, and okay, for PID1, in here we can see the overshoot is 7.2 at times of 0.91 second. Okay, in here the rise time is 2.59 seconds. Okay, this is the result for Kd when Kd is increased while Kp and Ki is constant. And okay, this is my result from the graph that I have done. Okay, and this is my calculation. Okay, next is for task 4.1. 4.1, you can see without PID controller. Okay, this is my program, my coding, and we will run. And so you can see here the response for task 4.1 without the ID controller. Response time and press time. Okay, so you can see here the settling time is 1.49 second and rise time is 0.833 second. Okay, this is for task 4.1. Next, task 4.1, but with the ID controller. Okay, this is the coding for task 4.1 with PID controller. Okay, as you can see here, for KP1, 300, Ki and Kd is 0. KP2, 300, Ki2, 10, and Kd is 0. For KP3, 350, KI 0, and KD 3 is 50. For KP4, 300 and for C4, the KP is 350, KI 200, and KD is 50. Okay, then you run and see this is the result. This is the result that I get from task 4.1 with PID controller. Okay. Then here. Okay. So this is my result for the final task. Okay, and this is the table. Okay, this is all from me for lab 5. Thank you.